graders, so we just learned how to change numbers into standard form and scientific notation in our previous lesson. In this lesson, we're actually going to learn how to compute. So we're going to learn how to add, subtract, multiply, and divide numbers in scientific notation. The standards we're going to be doing is 8th grade equivalent expression standard number 3 and standard number 4. Let's go ahead and get started on today's lesson. One of the first things we're going to talk about in our video is how to multiply or divide in scientific notation. Then we'll talk about adding and subtracting later. So let's start with multiplying and dividing. When multiplying, what we're going to do is kind of something similar to what we've done before. As long as both numbers are written in scientific notation, what we're going to do is take our numbers times numbers. Again, both numbers have to be written in scientific notation. Numbers times numbers. Base times base. Now, reminder, when I mean bases, I'm talking about the things that are the same in the problem. The base is the number that has the exponent. So if our bases are the same, what we can do is we can add the exponents. This is something we learned in a previous example. So in this example, if I have 1.2 times 10 to the 5th power times 1.1 times 10 to the 7th power, what I'm going to do first is multiply the numbers first. 1.2 times 1.1. So that's what's happening here. Well, if I type 1.2 times 1.1 in my calculator, it gives me 1.32. That number's between 1 and 10, so we're good to go. Here, we have 10 to the 5th power times 10 to the 7th power. This is the base times the base. The numbers with the exponents, we multiply them. Well, if we're multiplying two numbers with the same base, all we got to do is add the exponents. So we have 10 to the 5th power times 10 to the 7th power. 5 plus 7 is 10 to the 12th power. So all we got to do is combine it all in one answer. The numbers multiplied to give me 1.2. The bases multiplied to give me 10 to the 12th power. So it's 1.32 times 10 to the 12th power. When dividing, you kind of do the same thing. Instead of numbers times numbers, it's numbers divided by numbers. Bases divided by bases. Again, base is the number that has the exponent, and as long as they're the same number, all we got to do is subtract the exponents. And since they're in scientific notation, the base should always be the same. So, we take 5.2 and divide by 3.2, we get 1.625. 10 to the 5th power divided by 10 to the 3rd power, we'll get 10 to the 2nd power because 5 minus 3 is 2. So this answer is 1.625 times 10 to the 2nd power. What we're going to do is we're going to practice some examples and see how we can do using these rules. So I'm going to go ahead and erase these rules and let's start some examples. Alright, in our first example, what we're going to be doing is we're going to be evaluating 7.2 times 10 to the 3rd power times 1.6 times 10 to the 4th power. Notice that both of the numbers are in scientific notation. That's key 1. If they're not, put them in scientific notation as we learned in the previous lesson. Now we can actually multiply these numbers. Now, since we're multiplying these two problems, we're going to take numbers times numbers and bases times bases. So the numbers we see are 7.2, and we're going to multiply that by 1.6. So I'm going to go ahead and type that in my calculator, which is right over here. So 7.2 times 1.6, and my calculator gives me 11.52. Okay, so I have 11.52. Now looking at this number would not be in scientific notation because 11.52 is bigger than 10. We'll talk about what to do after we're done with the next part. Let's do the bases. We have 10 to the 3rd power times 10 to the 4th power. Well, 10 to the 3rd power times 10 to the 4th power is really 10 to the power 7. Okay, so we got our answer when we multiply, and we got what it equals whenever we multiply the bases. We multiply the numbers, multiply the bases. So we might be thinking that this is 11.52 times 10 to the 7th power. And this is actually technically not written in scientific notation, because in order to write this in scientific notation, our number has to be between 1 and 10. Well, if I move the decimal from here, 1 over to the left, it's going to go between 1.1 now instead of 11.52. So I have 1.152 times 10. Now, since we moved the decimal to the left, what's going to happen is the exponent is actually going to go up however many times we move the decimal. When we move the decimal left, the exponent's positive. So we moved it one time to the left. So all we got to do is take that 7 and add one more. So this answer is 1.152 times 10 to the 8th power. So again, if you move the decimal left, exponent goes up. If you move the decimal right, and this is the decimal, just in case you want to write this down. If you move the decimal to the right, your exponent goes down. Based on how many times that you move the decimal, that's how much it goes up or down. So we move the decimal to the left, our exponent's going to go up by 1. It was 7, now it's 8. If we moved it twice, we'd take 7 plus 2 and get 9. Let's go ahead and do another problem and see how we can do this. Now, remember this rule because I'm actually going to be erasing this rule, so if you haven't got it, it's your time to pause it, copy that down, and we're moving on. Focus. Cool. In example 2, we're going to solve a problem that involves us multiplying two numbers in scientific notation, one being a number that has a negative exponent and one being a number that has a positive exponent. We're also going to express the answer in scientific notation. So first thing we're going to do is what we did in the previous question, number times number. So we look at the numbers in front. We're going to multiply 1.1 times 2.5 using our calculator. 1.1 times 2.5. This gives me 2.75. So looking at that number is written in scientific notation form. It's between 1 and 10. So we can actually leave that number alone. That's going to be the number we use. Now we're going to do the exponents. 10 to the negative third power times 10 to the 9th power. Since we're multiplying two numbers, same base, we add the exponents. So we have negative 3 plus 9, that equals 10 to the 6th power. So our answer, if we express it in scientific notation, is 2.75 times 10 to the 6th power. And this is all we got to do for this problem. We multiplied numbers by numbers, the numbers in front, and we multiplied bases by bases, and we added the exponents because our bases were the same and we were multiplying. So this is our final answer. In example 3, we're going to look at a real-life problem that involves population. In 2010, the world population was about 6,865,000,000 people. The population of the United States was about 3 times 10 to the 8th power. About how many times larger is the world population than the population of the United States? So we're going to figure out how much larger the world population is to the United States. Now, in order to do this type of problem, what we're going to be doing is division. Now, working with a number this big isn't going to very much be that easy to do. So what we might want to do with this number is actually change this number to scientific notation so we can figure out that answer. So we already have a period at the end. I'm going to act like it's my decimal, and I'm going to move this decimal all the way over here. It's going to go between the 6 and the 8. So I'm going to start with 6.86. I'm going to count how many times did I move the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 6.86 times 10 to the 9th power. That's how big the world population is. Well, the United States population was 3 times 10 to the 8th power. Now, we can figure out what that number is if we want to expand it out and write it in standard form, but for right now, for this purpose, we're just going to leave it alone. When you're usually talking about how many times something is bigger or smaller, what you want to do is take the big number divided by the small number. So in this case, we're going to take 6.86 and we're going to divide it by 3 times 10 to the 8th power. So we're going to write this as a division problem. Now, reminder, when we divide numbers, it's kind of like when we multiply numbers. We're actually going to divide the numbers first, and then we're going to divide the bases second. So, I got my handy-dandy calculator right here. 6.86 divided by 3. This gives me 2.288 and then 6 repeating, times 10. Now, all we got to do is take 10 to the 9, divide by 10 to the 8. 10 to the 9th power divided by 10 to the 8th power is 10 to the 1st power. So if we want to figure out how much bigger the population is, we're actually going to change this number to standard form. So if it's 2.286 times 10 to the 1st, well, that first means we're going to move the decimal 1 time. So the United States population, or the world population, is about 22.86 times larger than the United States population. So the entire world is that much bigger than the United States. Well, we could actually round this number up to get to the closest whole number. And this really tells us that the world population is about 23 times bigger than the United States population. In this next example, which is example 4, we're going to look at another word problem. This is probably the longest and most writing that you'll do for this lesson. And what we're going to do is we're going to look at how much larger the planet of Jupiter is in our solar system to the planet of Mercury. So it says the largest planet in our solar system is Jupiter with a diameter of about 143,000 kilometers. The smallest planet in our solar system is Mercury with a diameter of 5 times 10 to the 3rd power kilometers. About how many times larger is the diameter of Jupiter than the diameter of Mercury? So we're looking at another how many times larger something is than something else. So again, what that means is we want to change these both to scientific notation so we can actually multiply or divide them a little bit easier. So we're going to change the top number to scientific notation, 143,000. So again, in order to change a number to scientific notation, if it doesn't have a decimal at the end, we put a decimal at the end, and we move the decimal so it becomes a number between 1 and 10. So I'm actually going to move the decimal from behind 143,000 to between the 1 and the 4. So I'm going to write 1.43 times 10. And how many times did I move the decimal? 1, 2, 3, 4, 5. So this is 1.43 times 10 to the 5th power. We're going to divide that by 5 times 10 to the 3rd power to figure out how many times larger the difference is between those two. So again, I'm going to grab my calculator, if I can find it. Okay, I got my calculator. We got 1.43 divided by 5, because we take numbers divided by numbers. When we take 1.43 divided by 5, we get 0.286. Now think about that number. Is that number between 1 and 10? It's not between 1 and 10. That means we're actually going to change that in a second. But first, let's finish this out. We have 10 to the 5th power divided by 10 to the 3rd power. Now, we've already talked about the rules. We practiced it. Remember that if the bases are the same and we're dividing, we subtract the exponents. 5 minus 3, that's 2. So this would be 0.286 times 10 to the 2nd power. But again, this is not scientific notation because it's not a number between 1 and 10. If I have nothing in front of the decimal, then I have a 0. Well, 0.286, again, not between 1 and 10. So what we're going to do is we're going to move the decimal from here over to the right by 1 space. So now it's going to be 2.86. And now we have to follow that rule. Well, if we move the decimal left, the exponent goes up. If we move the decimal right, the exponent goes down. How many times did we move it? Well, we moved it 1 to the right. Since we went right, exponent goes down by 1. So, this means that it's 2.86 times 10 to the 1st power. Well, 10 to the 1st power means if we were to change this to its actual number, all we got to do is move the decimal 1 time to the right. So this means that it's 28.6 times larger. Now, if it says about how many times larger, all you got to do is round this number up. 28.6 is about 29. So this means that the planet Jupiter is about 29 times larger than the planet Mercury. That's a huge planet. Let's go ahead and try some more problems. adding or subtracting in scientific notation is what we're going to be practicing over the next few problems. One of the key things that you have to understand is in order to add or subtract numbers in scientific notation, the exponents must, again, they must be the same. What I mean is, you can't add scientific notation numbers if those little tiny numbers at the top, those exponents, are different. You cannot subtract those numbers if those little tiny numbers at the top are different. You can only add or subtract if those exponents are the same. They have to be the exact same number. So, if they're not the exact same number, what you're going to do is you're going to move the decimal left or right to make the exponents the same. I highly recommend taking the smaller exponent and moving it up to the bigger exponent, just so that way you don't have to move it later. But if you want to move the bigger exponent down to the smaller exponent, you can by all means do that. Remember, if you move the decimal left, your exponent goes up. If you move the decimal right, your exponent goes down. The biggest thing we need to understand is, before we add or subtract, we must keep the exponents the same. Even after we're done adding and subtracting, the exponent doesn't get bigger, the exponent doesn't get smaller. All we are is adding the numbers and keep the exponent the same. Let's go ahead and practice some problems. In example 5, we're going to be adding two numbers already written in scientific notation. We're going to add 6.89 times 10 to the 4th power plus 9.24 times 10 to the 5th power. Hold up. Before you actually try to add these numbers by typing them in your calculator, they're actually fairly easy to add, but we need to follow our rule. In order to add these two numbers, the exponents have to be the same. Now, here's our rule about the decimal. We're going to be moving that. If I want that decimal to move left, I'm going to raise the exponent up. If I want that decimal to move right, I'm going to drop the exponent down. So, as I said earlier, it's easier, or it's better in my opinion, to take the biggest exponent and raise the smaller one up to that exponent. So, this exponent is 5. This exponent's 4. I cannot add these because the two exponents are different. All we got to do is make the exponents the same, and then we can add these numbers. So I'm going to move the decimal to the left because I want this exponent to go up. Now all you got to do is figure out how many times you have to move from 4 to get to 5. Well, I only got to move it one time. So I'm going to take this decimal and I'm going to move it one spot over to the left. Since I moved that decimal 1 to the left, and now it's going to be 0.689. What that means is this exponent is going to go up by as many times as I moved it. So now it's 0.689 times 10 to the 5th power. What I'm going to do is I'm going to write the other problem right underneath it. 9.24 times 10 to the 5th power. I find this a lot easier to do if you kind of stack them like a hamburger. You put one on top of the other. Whenever you do that with decimals, make sure that you line up your decimals 100% right on top of each other, as well as you line up your bases 100% right on top of each other. Now, all you got to do is add going down. If I have 9 and I add nothing to it, I still have 9. If I have 8 and I add 4, I get 12. Drop the 2, carry the 1. 1 plus 6 is 7. 7 plus 2, that's 9. And then I have nothing plus 9, that's 9. The decimal just comes right down. So, right now, all I did was add the two decimals. I took 0.689 times 10 to the 5th power plus 9.24 times 10 to the 5th power, and I just added the two decimals. I get 9.929. Now, the biggest thing is, after we're done adding these, do we see it says times 10 to the 5th power? Biggest rule, keep that the same. When adding two numbers that are written in scientific notation, keep the exponent the same. Don't change it. The exponent only changes when you're multiplying or dividing. When you're adding, keep the exponent the same. So it's 9.29 times 10 to the 5th power. And we were able to add those two numbers because before we added, we actually made the exponents become exactly the same, and then we added our numbers. Again, you cannot add numbers unless the exponents are the same. So it's your job to make them the same. If you want to make the exponent go up to become the same, move it to the right. If you want to make the exponent go down to be the same, move it to the left. If you move the smaller exponent up to the larger exponent, typically you automatically get it in scientific notation. If you move the smaller exponent down to the bigger exponent, then usually you have to do another move at the very end to bring it back to scientific notation. So I highly recommend that you take the smaller exponent and move it up to the bigger exponent. In our next example, example 6, what we're going to be doing is we're still going to be adding numbers that have different exponents. So we have 2.85 times 10 to the 7th power plus 1.61 times 10 to the 9th power. Again, notice the exponents aren't the same. Our job is to move the decimal to make those exponents the same. I like to move the smaller exponent up to the bigger one. So what I need to do is I need to figure out how many times would I move 7 to get up to 9. Well, I'm going to move the decimal 2 times. Since I'm going to move the decimal up, I'm going to actually move the decimal to the left 2 times. So all I got to do is grab that decimal here, and I move it 1, 2, there's the decimal now, and I fill in this void with a 0. So what I'm really doing is I'm taking 0.0285 times 10 to the now 9th power, because again, how many times did we move the decimal? We moved it once, that brought it up to the 8th. We moved it again, that brought it up to the 9th power. These numbers are actually exactly the same, but now, since we moved it twice, we brought the exponent up 2 spots. We're going to add this number underneath. So again, I'm going to line up my decimals. I have 1.61. I'm going to line up the times 10 to the 9th power. And all we got to do is, since I have it written as a hamburger, I'm just going to add down. Reminder, our exponent at the end stays the same, so I want to write times 10 to the 9th power. That does not change. The end never changes. Now, 5 plus nothing, that's 5. 8 plus nothing, that's 8. 2 plus 1, that's 3. And 0 plus 6, that's 6. Drop my decimal down. 0 or nothing plus 1, that's 1. And what we just did was we wrote that in scientific notation just by moving the small exponent up to the bigger one. So we're done. We can only add or subtract again if the exponents are the same. In example 7, we have 7.83 times 10 to the 8th power minus 11,610,000. What we have to do is we have to change them both to scientific notation in order to actually add or subtract these numbers. So first thing, this is written in scientific notation. What I need to do is I need to look at this number and write it in scientific notation. Again, anytime you have a whole number or a number that doesn't have a decimal, put the decimal at the end of the problem. We're going to move that decimal so that way it becomes a number between 1 and 10. So I'm going to move the decimal from here all the way in between the 1 and the 1. So I get 1.161, because that's the numbers. Anything that has 0 I can drop off, times 10, and I count how many times the decimal moved. 1, 2, 3, 4, 5, 6, 7. So this is times 10 to the 7th power. So now looking at this, I have 7.83 times 10 to the 8th power minus 1.161 times 10 to the 7th power. Again, we're not allowed to add or subtract unless those exponents are the same. Again, it's still easier to take the smaller exponent and bring it up to the bigger exponent. So I'm going to change a 7 to an 8. All I got to do is ask myself, how many times do I have to move the decimal to make a 7 go to an 8? Well, I only got to move it 1 time. So I'm going to grab this decimal and I'm going to move it 1 spot over to the left. So really, this is 7.83 times 10 to the 8th power minus 1 point, or not even 1, sorry, I apologize for that. Well, it's 0.1161, so I'm going to put my decimal down here. 0.1161. I'm actually going to slide this over so there's more room over here. And since we moved the decimal over one space, they're both now 10 to the 8th power. As an addition, your exponents don't change. So I'm still going to have 10 to the 8th power as my final answer. Now all we got to do is subtract these numbers. Now this is 7.83. This is 0.1161. So anything that has an empty space, we can always fill with a 0. So I can add a 0 underneath the 7. And I can add 2 zeros behind the 0.830. Now we're just going to subtract. Well, if I have 0, I can't take away 1. So what I'm going to have to do is I'm going to have to borrow from the 3, change that 3 to 2. This 0 is going to change to a 9, and the last 0 is going to change to a 10. And now all we have to do is subtract going down. 10 minus 1, that's 9. 9 minus 6, that's 3. 2 minus 1, that's 1. And 8 minus 1, that's 7. 7 minus 0, that's 7. So our final answer, whenever we subtract these two decimals, is 7.7139 times 10 to the 8th power. I'm going to actually check my math in a calculator just to make sure I subtracted those correctly. So we have 7.83 minus 0.1161, and I get 7.7139. Exactly right. So in order to add or subtract numbers, again, make sure the exponents are the same. So you move the decimal in order to make the exponents the same based on how many times you need to move it. That'll make them the same, and then you can add and subtract like regular numbers. Hopefully you know how to borrow from previous numbers, so that way you can continuously work with subtraction without a calculator. But if you need a calculator, make sure you have one handy. You can always use the calculator to check yourself. I just recommend you try to do the math without one. Let's go on and do one more problem. So for our final problem, what we're going to be doing is we're going to be evaluating 6,450,000,000 minus 8.27 times 10 to the 7th power. We're going to express the result in scientific notation. What you want to do is first look at the numbers. Both of these numbers are not written in scientific notation. One of them is, one of them's not. So what we're going to first do, change that to scientific notation before we can actually subtract those numbers. So, again, I'm going to put a decimal behind the last digit, and I'm going to move that decimal all the way to the front behind the 6 and the 4. So I'm going to start by writing my number. I have 6.45 times 10. I don't need all those extra zeros, so I count how many times I moved it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 6.45 times 10 to the 9th power. We're going to be subtracting 8.27 times 10 to the 7th power. Again, we're not allowed to subtract these unless the exponents are the same. This exponent's 9, this exponent's 7. This means we have to move our decimal, and I'm going to move it up. I like to move decimals up to make my exponents equal. So I look at the smaller number, I'm going to move it up twice. So I'm going to actually move the decimal 2 spots. So what I'm going to get is that this is actually a 0.0827 times 10, and since we moved it up twice, it's no longer 7th power, it's now 9th power. So we're going to subtract this from this. So I have 6.45, and I'm going to put times 10 to the 9th power out here, minus, decimals line them up, 0.827 times 10 to the 9th power. Make sure that says 9th power. And so my decimals are lined up. I'm going to fill in this empty void with 0, 0, and I'm going to fill in right under the 6 with a 0. Now, I could go ahead and I could borrow from the 4, change the 5, change the 0, change the 0. I'm going to go ahead and actually do that, and then I'll check it in the calculator. So, since I see that 5 is less than 8, and I know I need to borrow with the zeros, I'm going to actually borrow from the 4. The 4 is now going to change to 3. The 5, since I'm going to borrow from it, it's going to change to 14 since I borrowed from the 3. This 0 is going to change to 9, and the last 0 is going to change to 10. I know that my exponent never changes whenever adding or subtracting, so it's still going to be times 10 to the 9th power. Now all I got to do is subtract. 10 minus 7, that's 3. 9 minus 2, that's 7. 14 minus 8, that's 6. 3 minus 0, that's 3. And then finally, 6 minus 0, that's 6. So this should be my answer. 6.3673 times 10 to the 9th power. I'm going to go ahead and check that in the calculator by typing in those numbers subtracting. So 6.45 minus 0.0827, and I do get exactly what we see here. 6.3673 times 10 to the 9th power. Hopefully you guys are understanding how to add or subtract. Remember, exponents have to be the same. And hopefully you guys understand how to multiply or divide. In order to multiply or divide, remember bases times bases, numbers times numbers. When multiplying, add them. When dividing, subtract them. In order to add or subtract, you have to make the exponents the same. Hopefully you guys understand this lesson. Make sure you like this video. Make sure you click that notification bell so you get notifications anytime I upload these videos. And if you haven't yet, subscribe to this video so that way you can always catch my videos anytime they're posted. You guys did awesome today. I'll see you tomorrow.